Hello and welcome. My name's Peter Hansons from Cloud Shuttle. I'm the founder there, along with my amazing team. It's really great to be with you on a Wednesday morning. We just wrapped up a couple of weeks of the Data Inch Bytes conferences, and we're back into consulting mode now. We're back doing our workshops and sort of implementing data platforms and doing data migrations, database migrations for clients at the moment. So really good being back on the horse, as they say. But I think we're going to have a lot of fun today with this webinar, which is building production grade batch pipelines. It's a workshop. It was one module of the 4-hour workshop that we did at Data Inch Bytes conferences on day zero. We had a really good reception to this particular webinar, and so hopefully, this webinar today is gonna you're gonna really enjoy it as well. So please do let us know where you're dialing in from, where you're uh, any questions or thoughts about Mage, any perspectives that you'd like to share. We'd love to hear your feedback and pull it up on screen if you're happy enough for us to do that. That'd be great, just to make these webinars a little bit more interactive than they can be. But without further ado, would like to sort of just dive straight in to the slides. So I'll just pull them up. So building production grade pipelines with Mage. So let's dive in. A little bit about us. Cloud Shuttle's been around for about 5 or 6 years. It's predominantly we're a data platform engineering company, um, homegrown. A lot of our clients are, I would say, in some of the more regional markets of Australia and New Zealand. But definitely we've worked with companies of all sizes, and really our sort of claim to fame, or our value proposition, if you will, is that we're able to sort of get things done quite rapidly at a really good price point. We're always looking at ways that we can leverage technology, whether it's some of the latest patterns in data engineering, definitely embracing generative AI and the like. We're always looking to leverage some of these best practices and new techniques to deliver value faster for our clients, because that's fundamentally what you're looking for, making sure that you can get the job done as quickly as possible. So that's definitely a big part of our value proposition. And what we're here today to showcase is Mage, really, and some of the technologies that you can use with Mage to indeed sort of get that outcome of getting stuff done a lot faster than you typically do with some of the more older tools. So a little bit about myself. I'm the founder and principal consultant at Cloud Shuttle, over 20 years of experience. Done a lot of stuff in the community. I started the Data Eng Bytes conferences and meetups about 9 years ago, and that's definitely been growing from strength to strength. But how I pay the bills is running a data engineering consultancy, and it's a lot of fun. It's a lot of fun seeing how clients kind of are able to completely transform their data platforms, get a whole heap more value out of it. And as well, it's really, really exciting to see how folks are learning new skills and sort of upskilling, embracing some of these more modern technologies. So sometimes that's probably the most rewarding aspect of the job, is to see sort of folks having that aha moment, folks being able to sort of, um, you know, add a few feathers in their cap, if you will. So today, what are we going to take you through? Well, there's a bit of a packed schedule for us today, but hopefully we'll be able to get through it within 45 minutes. So we want to just set up Mage for data orchestration, building data lakes with Apache Iceberg, running fast analytics with Starburst. So Starburst is the company behind Trino. So that's a distributed query engine, which is really awesome if you want to to combine multiple data sources together and do some really rapid discovery on, say, some of those really hard to reach on-prem uh, databases. Like, if you've got like a SQL Server or something like that, an Oracle database on-prem, definitely Starburst can really help you out in a big way. And then we'll take you through best practices for production deployments and then some cost optimization strategies. Very cool, very cool. Just yeah. So basically learning objectives for this webinar really is just what we took you through just then. Cool. So pre-webinar setup, I think we've got all of these environment variables that we need to set up. But you won't need to do this yourselves. I'll take you through all of it. But typically, you need, you click house, host and password, Snowflake credentials, and AWS access keys and stuff like that. There are more advanced techniques that you can use, like SSO and OIDC for some of them. But for a workshop purposes, we try to keep it simple. Cool. Understanding our data set. So we're based in Sydney, New South Wales, and obviously Sydney can get a little bit hairy when it comes to, traffic incidents and the like, and just generally navigating around the city. So I think New South Wales transport incidents is something that we can all relate to if you live in a big city, that's for sure. So what the data set is real-time traffic incidents in New South Wales, includes accidents, roadworks, hazards and special events. It's updated every minute with new incidents, rich location and severity information. That's always good for displaying data on a map and understanding the geography of it all. Um, so why this data set? It's perfect for demonstrating both batch and streaming patterns, real world complexity with real data quality challenges. This is data that's coming through live. There's typos, these sorts of things, missing data. There's geospatial and temporal components, which is always interesting and, definitely a very relevant data set for transport, smart city, and emergency response uses. So this is a little bit about what the data actually looks like. So as you can see, there's a few nested objects. You've got the lat long coordinates in there, and bit about the location and the severity, and are created at timestamp. So why build a modern data stack? And occasionally modern data stack can be a very loaded term, but I think it's the term that we've got at the moment. But I think we can all admit that some of the traditional challenges that we've got around slow ETL processes taking hours, very expensive proprietary tools, lots of vendor lock-in, can't scale with data growth, and no real-time capability. These are quite common challenges that we see out there in the market, especially the no real-time capability. We won't touch on real-time in this particular webinar, but we'll have a follow-up soon enough for you on that regard. But basically, a modern solution can get you that real time data processing. It's cloud native and scalable. Open standards such as like Iceberg and Kafka. Uh, Best tool for each job. So we're not just trying to get one single platform to do absolutely everything for you. We're taking a modularized approach, but also a modularized approach that can be easily sort of glued together. And then, if you need to do AI and ML, and who doesn't these days, that integration's built in. So basically, what we're seeing is, from a business impact perspective, is faster insights, lower cost, better user experience, and and let's not downplay user experience, because developer productivity is king these days. Oftentimes, the biggest cost in our technology stack is not any particular technology, but it's the actual users and the developers that are building it. Cool. Let's take a look at the batch pipelines then. Okay, so we've got a comment from Surrender. So thank you so much for the kind words, Surrender, before we dive into the module one of batch pipelines. But yeah, keen to hear your feedback in a tick. Awesome. So we're obviously only going to go through module one today in this 45-minute session, but stay tuned for next week where we'll do another one as well. Cool. So we're going to build a batch data pipeline with Mage, Apache Iceberg, and Starburst. So the goal is to build a production grade batch pipeline that handles incremental data processing, deduplication, and efficient storage using Apache Iceberg's table format. So first up, what is Mage? It's a modern data pipeline orchestration tool. It provides, visual pipeline orchestration and helps you to build, run, and monitor data pipelines. Key features is its code first and very developer friendly user interface. You'll see in the UI that it's quite modern in that regard, which is always nice. It's always nice to use a visually appealing tool regardless of its functionality, but that's kind of what Mage does. It's not only visually appealing, but it's also extremely powerful as well. It's got built-in data quality checks and testing, which is phenomenal. Easy scheduling and monitoring, so you're not having to set up really difficult cron jobs and tasks and lots of distributed sort of things going on. Easy scheduling and monitoring, as I said, supports Python, SQL, and R. So if you want to have mix and match your code blocks, then that's totally possible. And then also it's got real time pipeline execution visibility. So as you're seeing things execute, you're getting that constant feedback. And if things are breaking, you're able to just hop in there and quickly fix it up so that there can be minimal impact to production. Some of the other things are around sort of reduced the development time. These numbers, 60%, obviously they can vary, but I dare say that that's kind of the minimum that you're going to experience. Mage is phenomenally fast at building out data pipelines, and I think you're going to just even after a couple of hours of using Mage, you're going to see some quite dramatic speed ups. There's also a lower maintenance overhead. There's a lot less moving parts. I know with some other popular tools like Apache Airflow and things like that, um, you know, a lot of folks have got entire platform teams just looking after their Airflow cluster. And even with some of the managed services, they're not a walk in the park to sort of implement and maintain themselves. So, um, low maintenance overhead is a big one. Improved data quality and reliability, and faster time to value for data projects. Like I said, the developer productivity is phenomenal with Mage. So Apache Iceberg, it's been around for a while. It's been around for as long as Trino, or maybe just a little bit after Trino. But effectively, what it does is it solves a lot of the challenges that we had with the Hadoop ecosystem. It's bringing back a lot of database semantics to table formats. So time travel and rollback capabilities, ACID transactions for data consistency, schema evolution without downtime, and automatic file management and compaction, and multi-engine compatibility. And we'll see that today that you can use it with Trino, you can use it also with Snowflake, ClickHouse, with Amazon Athena, which is Trino under the covers as well. So there's you can use it with DuckDB. There's a lot of sort of flexibility around which compute you can use. So you can definitely think of Apache Iceberg as the storage layer, and you can just pick your own compute to go with that, which would be the query engine side of things. So the business benefit is that it avoids vendor lock-in with open standards. Definitely, at least a 40% reduction in storage costs through compression. It leverages Parquet to store the files. So obviously, Hadoop was largely sort of like CSV based solution, which wasn't great. Um, Improved query performance and data versioning and audit capabilities. Awesome. So that's pretty much Iceberg in a nutshell. Really, how you can think of Iceberg, especially in the way that we've got it rolled out. Typically, Iceberg's got a REST catalog that contains a lot of metadata about the files that you've got stored. So typically in Iceberg, you've got a collection of um, Parquet files. Those Parquet files themselves have got a lot of metadata associated with them. Parquet files store data in a columnar fashion, and they've got like min and max values of each particular column, such as if you've got a date field, a date column that might have, um, the earliest date and the most recent date of that particular that column in the min max fields, and that helps when you're doing um, a query in your where clause, and you might sort of want to filter by, say, a particular date range. Um, it'll go and then read that metadata in the Parquet file. It'll first read the metadata in the Iceberg REST catalog, REST API, the Iceberg catalog, check which files have got uh, are associated, have the range of those particular dates, then go into those files, and then it'll basically determine which particular files are necessary to read from for that particular query, and then of course, you know, beyond that, it's about sort of, in your select clause around sort of which columns to fetch, and so all of this is around really efficient data fetching, and obviously, if you're storing your Iceberg data on S3, reading from less files means that you're going to save money because you get charged per file read, um, amongst other things, and also like Parquet's binary format stores the data highly compressed. It only fetches the data that's read, so it, each particular column, and so there's lots of like data transfer savings as well. So lots of benefits from using Apache Iceberg in terms of, especially over something like a CSV file, especially a CSV file with Hadoop or something like that. So, what is Starburst? Starburst is a fast analytics engine, and it's a distributed SQL query engine that enables you to query data anywhere at massive scale. So, Starburst isn't just a cloud offering or something like that. It's definitely one of its main benefits is rolling it out into your on-prem infrastructure, so that you can kind of get access to all of the data that might be typically hard to get to. So we've all seen those like data migration projects or platform modernization projects with 5 to 10 year timelines. Really slow and arduous to get immediate business value out of. That's pretty much what Starburst solves. It makes all of those on-prem databases accessible right from the get-go, so that you can do a lot of data discovery up front, um, and give access to the business users that would benefit most from having access to that particular data. So it's really beneficial in that regard. So aside from that, and where Starburst Trino came from was, it came from Facebook, where they had that exact issue. Lots of on-prem data that they wanted to bring together, and they wanted to somehow build out a distributed query engine that could allow them to access all of that data efficiently, and so, but now you can use it across the cloud and on-prem as well. So it's really awesome for that, and super flexible. So some of the business benefits are, lower compute costs, unified access to all your data sources, and reduced data movement and deduplication. Uh, data duplication. So rather than having the need to basically, typically in those big data modernization projects, you would just do a big lift and shift from the get go, because that's kind of the quickest pathway to success, if you will. And so what you do is you just basically um, you know do a full copy of all of these on-prem data sources into your data lake, and and because no one's really taken the time to sort of go through any of those data sources, you get that classic data swamp where it's just a whole bunch of everything just thrown into an S3 bucket without a lot of care and librarian work, if you will, around the data. And so I think you know, uh, you know, having the possibility of like being a lot more deliberate about what data you're replicating, and only replicating the useful stuff, and just having access to the original data sources, that definitely sort of helps make your projects a lot more agile, and makes your data migration efforts a lot more intentional. So keen to hear your thoughts on if you can see any benefits to taking that approach rather than doing massive lift and shifts, taking a much more intentional approach about what data you're migrating across. So do leave some comments on the live stream if you've got any thoughts on that. Awesome. So let's see how this all hangs together. So this is the pipeline architecture. So as you can see, we've got the API from New South Wales Transport. Massive thanks to those folks for making this data available. I think you can just sign up and get access to the data, which is really awesome. Then we've got our major AI pipeline. So we've got a few concepts going on there. Basically, we've got a data loader block. Major's got really good coding principles built into it to keep your code dry. That basically means that stands for do not repeat yourself. And what it's all about is sort of breaking your code down into modular artifacts, um, and uh, Mage helps you to do that by thinking of your um, data pipelines in three blocks: a data loader block, which basically extracts all of the data from a particular source, then a transformer block that helps you to do transformations, such as a bit of data cleaning, or just appending sort of typical sort of like ETL standard practices, like appending like loaded at timestamps and these sorts of things, and the process that was actually doing the work. And then some data enrichment. Maybe you're going to fetch some data from another source to sort of update this particular data, or do some transformations to make that raw data a little bit more accessible, such as like a couple of boolean values, or if there was a particular incident on this particular day, or if this particular timestamp was during a peak hour period or not. And then, of course, it's got the data exporter block, which is we're going to use an iceberg exporter. So Mage's got a lot of these built-in exporter blocks that we can leverage. But typically, you know, if you're not getting the functionality that you want out of the library of exporter blocks, you can write your own custom exporters with a whole bunch of built-in logic, and leverage utility functions to sort of help maintain that whole dryness of the code. So I think it's a lot of there's a lot of really good practices that sort of you know help guide you along in the direction of building really robust data pipelines. And did I mention that there's inbuilt inbuilt data testing capabilities within Mage? So that definitely helps as well. So that's the major aspect side of things where we're doing the, I guess you can call it ETL side of things. We're going to store the data in an Apache Iceberg table on S3. So in the Amazon Glue service, AWS Glue service, there's um, there's a thing called the Glue Data Catalog, and that's actually free. So we can use the Glue Data Catalog as our um, Iceberg REST catalog, if you will. And so effectively, what it is we're going to be storing a bunch of our Parquet files on S3, and then basically pushing up all of the metadata for how all of those Parquet files are organized into the table format to the Glue data catalog. And so uh, effectively, all we're really paying for is not so much our interactions with the Glue data catalog. It's just basically our data fetching from S3. Um, and of course, because of Iceberg, we've got really efficient data fetching from S3. So, um, well, because of Iceberg and Parquet. And then finally, we're going to query all of this data via Starburst Analytics, which is going to be a lot of fun. This is their SaaS solution, Starburst Galaxy, so that's going to be really good. Just to make it clear to differentiate between the on-prem and the sort of SaaS version of the product. Cool. So I hope you're hanging in there with us and you're getting a lot of value out of this webinar. Please do leave some comments if you've got any questions. So moving along into the code now. Awesome. So this is what a raw data loader looks like. So effectively what we want to do is we want to fetch incident data from the New South Wales Transport API. We're going to show you the complete implementation shortly, but effectively what you've got is you've got the data loader decorator, and then we're going to hit this particular uh, API at this URL, and we've got the API key stored as an environment variable, and we're just going to do a little bit of light data processing and return it as a data frame. Next, once we fetch the data, we're going to want to do some transformations. So we've got the transformer decorator, and then we're going to do some cleaning of this data. So as you can see, we're just manipulating this data frame, plucking out the lat longs, and and also some other um, data such as region, suburb, and traffic volume, and then just filling in some of the NA values and things. So, and then of course we're going to return that as a data frame as well. And as we step through this, the data frame that we get back, we'll be able to inspect some of the records and even sort of visualize them into some basic charts as well, which is really cool. So data quality considerations, whenever you're doing this type of work, you want to do some, data quality checks. So we're checking for coordinate validation, make sure that it's like, there's 3 characters before the dot, or three numbers before the dot, these sorts of things. Uh, s- Text standardization, just to make sure that, it's using a particular casing standard. Um, Duplicate value handling, so that we're not double counting, especially important when you're sort of streaming data in that potentially could be unordered, and sort of have at least once guarantees around it, and then sort of like strategies around handling missing data, such as putting in unknown values and stuff like that. The big business impact is, clean data leads to reliable statistics and reliable business insights. Cool. So step 3 is the data enrichment phase. So what we want to do is just add some calculated features for analytical purposes, so that Our visualization tool needs to do a whole lot less computation, and just focus on displaying the data in a nice way. So as you can see, we're just doing some manipulation on the created at timestamps. So that's going into the data frame, plucking out things like the hour, day of week, is weekend, is peak hour, because obviously with incident data, if we've got lots of incidents around peak hour, that's going to have a much bigger impact on traffic flow than if we're just doing this, you know, at 2 a.m. in the morning or something like that, when there's not a lot of cars around. So, and then obviously, what we want to do is uh, build out a severity score, and we're just using a very simple method for doing this. And then, sort of adding some values and scores based on, whether it's peak hour and based on the traffic volume and the like. So, that's definitely a very useful bit of information for us. And as you can see, we've got that underneath that test decorator, we've got a quick little test to just do a few asserts and make sure that all of this data is ready for analytical purposes. Okay, so with all of that done, now it's time to export this data to Apache Iceberg. And the reason for doing this is, we want to properly partition the data, and handle sort of like the incremental nature of the data. So um, what we're doing here, obviously, there's the data exporter handler there, and as you can see, we've got a bucket called CSMH Workshop 2024. That was basically created last year when we were starting to roll out these workshops. And we've within that S3 bucket, we've got this table path, um, and then uh, and then we've got the database name that's obviously for the Glue data catalog, and the table name, which is um, the incidents table. We're in the AP Southeast 2 region, which is Sydney, and our warehouse follows this structure, which is the bucket and table path. Cool. And so here's some of the parameters that we leverage with the Glue data catalog, and some of the things that we need to create the tables and stuff like that. So that's a little bit. We'll go into a little bit more detail of how to interact with, create and interact with iceberg tables using the Glue data catalog shortly. There are obviously alternatives. There's a really cool project written in Rust called Lakekeeper, where you can spin up your own uh, iceberg data catalog with a REST API. And so that's just basically, a Rust sort of API front end, and and then a Postgres database for storing all of the database, uh, all the all of the metadata. And there's obviously a few other alternatives to Iceberg at the moment. I think probably been um, we've seen Duck Lake and the like as well. So awesome. So hopefully getting a few folks sending some nice comments. So Eddie Chi, who I've known for probably 15 years, Eddie. Yeah, so he's finding it really informative, and Sugat is finding this very insightful as well. So that's really cool. Awesome. So let's keep moving along. Okay, we're up to analytics with Starburst. So as we mentioned, Starburst is a query engine, so you can just write some SQL with it, and we can fetch all of that data from the Iceberg table. So with the configuration of Starburst, obviously it's a SaaS app. We'll have to provide some configuration to connect that SaaS app to our AWS account. And so effectively what we've got is that we'll provide it a catalog name, do some S3 authentication via a cross account IAM role, uh, specify the table format, which is Iceberg, the meta store, which is AWS Glue in AP Southeast 2, and then the default bucket where we want to fetch all of this data from. So, and then uh, you know, Starburst does the rest with its Trino data fetching and things like that. Awesome. So it's demo time. So let's just give us a couple of minutes to set everything up and dive right in. Awesome. I'm just going to get my other screen working and then we'll pull all this stuff up. In the meantime, I'm keen to hear like who's actually working with Mage at the moment, or if you're using a different orchestration tool, what you're using, how's that going for you, and if you've got any sort of you know preferences on, I guess, any favorite query engine that you're having a lot of fun with. There are a couple of few different options out there these days. I wouldn't say that Mage is the only option that you can use. It's definitely one of the better options that I've seen uh, being used out there. So, if you've got a better one, or if you feel very passionate about the subject, very happy to hear from you in the comments. So please do chime in. Okie dokie. There's always a little bit of things to put together with these things. So I think we should be good to go now. Just gonna see if I can collapse down a few of these things. Okay. Awesome. Okay, so we've got some code here. Just a few things. Hopefully you can all hear me well enough. So we've been running these jobs quite frequently over the last little bit. And here you can see we've got the triggers tab, and so where you can sort of do a typical like cron schedule, and it'll sort of output when your next scheduled run is, and we can sort of dive into the logs here and sort of see what's been going on and things like that. Just trying to give you a bit of a feel for some of the other features that Mage has got that that we might not get time to take you through at the end of this, but hopefully it all makes sense. But yeah, so there's a really robust, uh, you know, uh, observability tooling within Mage, so not even needing to reach for a separate tool. And obviously, you can set up lots of lots of different things around sort of like SLAs and retries and all sorts of different things. So definitely worthwhile sort of checking out the sort of the logging and monitoring aspects of Mage, as well as like you can do sort of like Slack alerting and these sorts of things. So definitely, if you've got any sort of like advanced questions about or advanced use cases with Mage, definitely just feel free to reach out. Both myself and the team are more than happy to help you with any questions that you've got. Awesome. So here is Mage. So um, this is effectively, I will go through and run this in this particular block here. But effectively, if I was to build this myself, I would open this in a new tab. I would create a new pipeline, start from scratch, because I know what I'm doing, and select the batch pipeline and then create new pipeline. And then, of course, what I'll do is I'll create a custom base template generic a Python block, and it'll come up with a nice new name for us, which is great. And so this will have a lot of the base template that we need. And so if I was to sort of grab all of this code and copy it across, I can just paste it in there. I can run this code, and hopefully it'll output some data for me. And as you can see, that ran pretty fast. That was 1.53 seconds. It's a Jupyter Notebook interface. I can quickly just update and edit all of this code if I'd like to, and I can just quickly inspect the data in this nice little data frame down the bottom. So lots of really good, nice features and um, really great developer experience for me. Cool. But what I might do is I might just run the code here instead. So effectively, what we've got is we've got this data pipeline. It's fetching incidents from the New South Wales Transport API, and then plucking out some of the features that we're interested in. Obviously, it's a nested JSON structure. We'd like to sort of flatten that out into a data frame, and so that's kind of what we're doing here. Okay. Um, so hopefully that all makes sense. And we're doing a very basic test here, and then sort of returning that data frame. So that's what we're doing there. So next step would be to do the cleansing. So if I was to do that in my new data pipeline, I would scroll down all the way down to the bottom, and then I'd chain up another block. And instead of doing a loader block this time, I'd go for a transformer block, use the base template generic transformer block, and then I will just copy this code and jump in and run that code. Let's see how this goes. Cool. That was just so fast, wasn't it? So 1.18 seconds, almost like this is something I prepared earlier, like on one of those fun cooking shows. But no, it's just really fast. The way that it passes data from node to node is really awesome, actually. Like it's using some really cool technology like Apache Arrow in flight um, to pass data from one node to another. So kudos to the Mage engineering team for putting together such a blazingly fast product. But yeah, as you can see, we're using pandas here. We could use polars, I guess, but we're just keeping it nice and simple for this demo purpose. Uh, Speed wasn't our highest priority in this case, but as you can see, we're using that transformer decorator, and then just doing a whole bunch of cleansing work to fill in those NA values and the like. So hopefully that all makes sense. Um, cool. So now we've just returned that data frame, and we've got all of that data available for us to now sort of start to do a little bit of further transformations to prepare it up for transformation. So to prepare it up for data visualization. Cool. So after that, we're moving on to the you know basically some of the uh, data transformations where we can sort of get some severity scores and help to sort of pluck out some of that location data and the like, so that we can know what's going on with our data and make it easy to work with from a data analytics perspective. So I've just run this transformation block, and the data's kind of just again being displayed. Obviously all those tests they've passed, and we've got this data um, exported out into the data frame. So what we've got is a bunch of booleans outputted. So that's really nice and easy to work with. We can see whether this incident is impacting the network, what sort of traffic volume, and the like, and just kind of we've got also some nice booleans around sort of like has a valid location, what hour of day, day of week, is it a weekend, is it a morning peak, that sort of jazz. So and also the location category. So all making it super nice and easy for us to play with. And that's a bit of a summary of what went down. Cool. couple of UI errors that's coming up, but I'm sure nothing too much to worry about. Famous last words. That is starting to actually annoy me. That pop up. I wonder if I can refresh this page and get rid of it. Awesome. So, like I said, that one that we did just then, what we did was we chained another transformer block. So basically, you can chain lots and lots of transformer blocks together. Um, but if you know, but I guess you can't really do the same with loader blocks. You can only kind of load one block together, um, one at a time, and then for your exporters the same. Um, but I guess you can fan out. That's a different story altogether. So now we basically want to do the another exporter, which is uh, doing the Python-based template generic. Like I said, I mean, if you wanted to go direct, we could use like say the Apache Iceberg exporter, but we just want to do a couple of custom things to it. But you can even export this data to MongoDB and a whole bunch of other places. So lots of really good, pre-built functionality for you, such as even if you're using what is it, Airtable. So that's pretty handy indeed. But I'm not going to play around too much with live coding today. I'll keep it nice and simple. So we'll just go back down to our exporter block where we're exporting transport data to Iceberg. So I'm going to hit execute on this code. This will take a little bit longer. Just to take you through what's going on here. Obviously, we're using the Glue catalog for sure. But one of the things that we're doing here actually is we're using PyIceberg. Reason why we're using PyIceberg is it's really good at append only operations, and it allows us to leverage the compute within Mage to write the data out um, uh, to Iceberg rather than doing multiple hops either via Athena or some other compute service. So Mage obviously has enough compute within itself to do a whole bunch of data processing jobs. Um, if you don't want to, um, uh, but you've got lots of options with Mage. You can call external services to do all of the compute for you, or within Mage you can fan out to subtasks to run, different say instances of Mage as tasks. Say if you're using Fargate, you can spawn lots of Fargate tasks. If you're running Mage there or on Kubernetes, you can spawn lots of pods to run lots of tasks. Fan them all out into say 1,000 tasks. Say in a map reduce style process, and then collect that all back together and export that all out into say Iceberg, if you will. So hopefully that all makes sense. So as we can see, we've got the data exporter decorator. You've got your bucket, table path, database name, table name, region, and warehouse. So that's a little bit of the configuration that we're using here. Again, just sort of uh, dropping some of the columns and things like that. Making sure that we've got all of the right timestamps and stuff like that. Uh, Setting a few things such as the thing with PyIceberg is it's quite verbose. We need to sort of feed it a schema and these sorts of things. There are tools like AWS Wrangler that handle all of this for you, but I guess what you need to do is you need to that would make leverage um, Athena rather than just use Mage's native inbuilt compute. So we've chosen the more efficient way of doing it, but it's a little bit more verbose from a coding perspective because there's no automatic inference of the table schema from the data frame. But I guess we could probably um, do a little bit of work around that, but we just wanted to make sure that um, it all works correctly. Cool. So that's pretty much all understood, I think. And then effectively just doing, where there's an existing table, just appending all of that data. Cool. So as you can see, that's all appended, but I think we've got a bit of an error at the end. So we'll have to investigate that, and that's probably why I got that pop up. So we'll do a little bit of investigation around what that secular reference is all about, and then we'll sort of get that fixed up for our next webinar. So I'll just pull up our Starburst Galaxy instance now. So we'll just jump into this particular query where we've got some of our CS incident data. So as you can see, it's sort of querying from the same data set, Cloud Shuttle 2507 data. So this is the database that we built for our workshops that we delivered for the Data Eng Bytes conference. It's the New South Wales incident schema, and we're querying the incidents table. So if I do a quick query of that, this probably needs to wake up the service, so it might take a little bit of time. But we'll kick this query off and just have a little bit of a play around with the data. So obviously a lot of this elapsed time is just around waking up the service. Typically when it's ready to go, it's a lot faster than this, but this just gives you an indication of, I guess, the power of Starburst in that it can read from Iceberg, it can read from a lot of different places. So yeah, so as you can see, we've read all of these rows. I've just done a limit 10, and we've outputted all of this data. And then obviously what we would want to do is eventually we would want to put this into a nice dashboard to just display a whole bunch of really cool insights to you. And that's exactly what we will be doing in a subsequent webinar. So that's it for the demo component of this webinar. I'll quickly flick back to the slides, and then once we've done with this, I'll invite you to our next webinar next week, where we'll tackle, I believe, real-time streaming and hopefully showcase a really cool demo for you. And then later on, we'll do in our third webinar, we've got a really cool interactive dashboard that we'll present to you, which is going to showcase some generative AI derived analytics. Cool. Let me get my screenshot again. Awesome. All right. So demo complete. So as you can see, what we just built, we built a whole bunch of data pipeline, well, a data pipeline with automated data quality. So it's all sort of automated for you. If something breaks, it'll just alert you, and you can sort of go ahead and get that fixed. Smart data enrichment, so automatically calculates severity scores, peak hour detection, that sort of jazz. So that's all handled for you, no manual processing anymore. You've got instant analytics, reliable, scalable, built-in error handling, and you've got a super cost-effective storage solution. So you're paying pretty much peanuts for this thing. So the ideal use case for this is, like, Iceberg really likes append-only data sets. So, really good for historical analysis, compliance reporting, data science, where you've got large swathes of data, and business intelligence, where you're not doing a huge amount of upserts and stuff like that. So, pro tips around building data pipelines with Mage: always use @test function or data quality check function in Mage to validate the data. You can use conditional blocks. accumulate at least 100 megabytes of data before writing to Iceberg to reduce the full small files problem. I think Iceberg, the sweet spot for Iceberg file sizes is around the 500 megabyte mark, and enable metadata cache for faster access to datasets. Iceberg, and make sure you implement merge on read. For updates where you need to do them, use merge on read instead of copy on write for better performance. So I know a few of you have been putting a few comments in the chat, but any questions? All right, so had a few nice comments. So thank you very much from everyone. Thanks, Jan, and then thanks, Sunil. Really appreciate it. Cool. So basically, I know it's nearly lunchtime, so you're probably thinking about grabbing something to eat. So that's all good. If you do want to reach out, if you've got any questions about anything that I've shown you today, me and the team are happy to sort of jump on a call and sort of walk you through. There's no question, you know, too difficult or too simple. We'd love to chat to you and help enable you and your team to get better at data engineering and the like. And yeah, if you need any assistance in building out a data platform, please don't hesitate to reach out. But just wanted to thank you once again for sticking with us, giving us an hour of your time on this Wednesday morning. Have an awesome lunch, and stay tuned for our webinar on next Wednesday and the Wednesday after. I think next Wednesday is going to be real time streaming, and then with ClickHouse, and then the Wednesday after that's going to be agentic analytics with Snowflake's Cortex AI. So lots of really good fun insights to be gained from both of those sessions. And what you'll see is really cool use cases of Mage for our data pipeline building. So it's going to be a lot of fun. And just please do send through any feedback that you've got from this session. Thanks once again. Really appreciate it. Chat soon. Bye.